Jack uses the formula area equals a half AB sine C to work out the area of a triangle. For this triangle, he's measured A to be 7.8 centimetres, and that's correct to the nearest millimetre. So straight away when it's saying this, I'm assuming this is a bounds question. B equals 5.2 centimetres, and that's correct to the nearest millimetre as well. And C equals 63 degrees, correct to the nearest degree. Calculate the lower bound for the area of this triangle. So AL, A lower, will be equal to 1/2 multiplied by, now if I want the smallest area possible, I want to have the smallest value of A multiplied by the smallest value of B multiplied by sine of the smallest angle. These have all been multiplied together, so I want the smallest of each of them. So it's going to be A lower times B lower times sine of C lower. So let's work out what the lower bounds of each of these are. A was 7.8, correct to the nearest millimetre. The nearest millimetre, well that's 7 centimetres, this is 8 millimetres there. When it says 7.8, that's saying 8 millimetres. So the smallest that could have been would be 7.75. That's the lower bound for this. That's the smallest that it could possibly have been to have still rounded to 7.8 to the nearest millimetre. The lower bound for B will be 5.15, because again, that's the lowest that B could possibly have been in order to round to 5.2. And C, the lower bound of C, would be 62.5, because that's the smallest that the angle could have been to have rounded to 63 degrees to the nearest degree. So if we substitute each of those into the rule, let's get our calculator. So 1/2 times 7.75 times 5.15 times sine of 62.5, and we get 17 points. Now it doesn't tell me how many decimal places to write my answer to, so I'm going to write down the whole thing. So 17.701409994, and that will be my answer. If I had to round it to one decimal place, it would obviously be 17.721 dp. But I'd write both of them if it's not specified.